Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are checking your answers. You have homework about general wave properties, paper 1. You have part 1 and part 2 later on. Let's start question number 1. Okay, question 1 is asking you what's meant by the frequency of water. We discussed the definition of frequency in your classwork, and we said frequency means number of complete waves, oscillations, cycles, vibrations produced in 1 second. Okay, so it's not a distance at all, it's not a distance. Maximum vertical displacement of the wave, it's the definition of amplitude. No, it's not this one. So the answer is D, number of complete crests passing a point per unit time. So it's the definition of frequency. It's measured, as we said, it's measured in hertz, and it's number of waves produced per second. Question number 2. We have here a wave moves along the surface of water. What is the wave length of the wave? Okay, wave length is the distance between two successive crests or two successive troughs. Okay, so you have this distance or this distance, or it could be the distance between a certain point in the wave and a similar point in the next wave. Also, this representing the wave length, lambda. So all these are representing wave length. Okay, guys? Okay. So this here is also lambda. Okay, so the answer here is the distance between one crest and the next crest is the correct answer. Question number 3. We have here a toy boat floats on water in a tank, and the boat at first it was stationary. Stationary means not moving. It is at rest, not moving. And when a stone is thrown into the tank, this causes a transverse water wave. What do you know about transverse water waves? That if you have the wave is traveling in this direction, you will find the particles of water vibrate up and down at right angle to the direction of wave travel. So how does the boat behave as the wave passes? Here, the boat, it will stay, but it will vibrate up and down. So it stays the same distance from where the stone hit the water, and it will vibrate up and down. So it will not move, anywhere, just vibrating up and down. Is it clear? So the answer is D. Question number 4 about transverse and longitudinal. I find it a challenging question because some candidates, they got confused between radio waves and sound waves. Guys, radio waves, they are one of the members of the electromagnetic waves. So they are all transverse waves. All electromagnetic waves are transverse waves. But sound waves, they are longitudinal. So here, transverse waves, we have radio waves. Longitudinal waves, we have sound waves. Light is transverse, correct, but radio also is transverse. Here, sound is transverse. No. Water is longitudinal. No, water is transverse. Water and light. Water is transverse, right? But light is transverse also. Okay, so the only correct one here is the second one, B. Okay. Question number 5, which label here, labeled distance is the wave length. Okay, again, if you can draw just the line for representing this rest position, or sometimes we call it the undisturbed position before the particles vibrate up and down. So this A representing the amplitude. He is asking you about the wavelength. So the wavelength is the distance traveled by one complete wave. So, or the distance between a certain point in the wave and a similar point in the next wave. So the answer is C. So distance C representing the wave length, and it's very important if you draw or color this to understand that this means one complete wave. So one complete wavelength is the distance traveled by one complete wave. Is it clear?
Subscribe for more videos. I love physics blender. I love physics blender. I love physics blender.